So next topic is in the chapter 4 is aqueous reaction and solution stoichiometry. So in this topic we will study about first acid, base and salts. What are the acid, what are the bases and what are the salts? So acids are those compound which produces hydrogen ion in water and then give negative ion. So H is for hydrogen and for as a negative ion. And base are those compound which produces in the water hydroxyl ion, OH hydroxide ion minus, and M stand for metal or positive ion. And here the salt are the metal and negative ion are combined to form salt as a, and they produces metal ion and minus negative ion in the water. So these are the salt, acid and bases. So let's talk about more about the acids. So acids are those substances which produces substance that ionizes to form hydrogen ion H plus, and because H plus consists of only a proton, so acid are often called proton donor. So H plus, remember hydrogen have one atomic number, and one atomic number means one proton and one electron. And how this hydrogen become H plus? Because we remove one electron from the hydrogen ion, so then this will become H plus. So H plus have only one proton, that is why acids are also called proton donor, because they give H plus, means H proton. So acid increases the concentration of hydrogen ion and decreases the concentration of hydroxyl ion in the aqueous solution. And and these acids can be monoprotic, diprotic and triprotic. Mono means 1, di means 2, tri means 3, protic means proton. So acid can, if they are giving only one proton per molecule of acid, that is called monoprotic. If they are giving 2 protons per molecule, that is called diprotic, and if they are giving 3 protons, they are called triprotic molecule. For an example, HCl, when it dissociate, it give only one proton, so this is a monoprotic. So monoprotic is HCl. Nitric acid also dissociate, give H plus and NO3 minus, so only one proton, so nitric acid is also monoprotic acid. Sulfuric acid is a diprotic because it give 2 H plus and then sulfate ion minus minus, so diprotic will be H2SO4. And then acetic acid is also monoprotic because it give acetate ion H plus and then CS3 COO minus. So acetic acid is also monoprotic, but it's weak acid. Triprotic will be example as a phosphoric acid S3PO4. They give 3 protons. So this was about the acids, and let's see the properties of acids. Acids are called or considered as a proton donor because they give H plus in the aqueous solution, and they increases the concentration of hydrogen ion. They decreases, on the other hand, they decreases the concentration of hydroxyl ion. Acid react with hydroxyl ion to form water molecule. They have sour taste, they are corrosive in nature, and react with organic dyes to yield a color change. They also change the blue litmus paper into red in the presence of an acid. So blue litmus paper, this picture shows that blue litmus paper will change the color to red. This is the black and white image, so you cannot see the color here, but blue litmus paper will change color red in presence of an acid. So these are the properties of the acids. And acid, just like we have study about the electrolytes, they can be strong electrolyte and weak electrolyte. Similarly, acids are strong acid and weak acid. So strong acid produces hydrogen ion very quickly, very fast in water. Hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, chloric acid, and perchloric acids. So these are all hydrochloric acid, all strong acid, and other than any other acid is considered as a weak acid. So you have to just remember or memorize these 1 2 3 4 5 6 7 7 acids are the strong acid, and remaining will be weak acid. Next is we have to review very quickly about the nomenclature of the acids. If you remember from chapter number 2, we were studying about the nomenclature of acids. So acid nomenclature review: simple anions, if they have Cl minus, chloride for the binary molecule, ide ending indicate a binary compound and composed of only two elements. For example, sodium chloride, potassium fluoride. So binary compound or binary acid. So when chloride react with H plus, so it gives HCl, hydrochloric acid. So we will see some more review about the nomenclature of the acids and anion. Before acid, we need to look at about the anions, oxyanions. Remember, if we have 3 chloro, 1 chlorine and 3 oxygen as a polyanion, then it is called 8 chlorate. If it is 2 ide, it would be chlorite ion, and then 1 oxygen with hypochlorite ion, and there are 4 oxygen, there will be perchlorate ion, so chlorate. And the acids of these anion acid nomenclature: ide will go to hydroic acid, 8 will go to ic acid, and ite will go to us acid. So for an example, chloride will become hydrochloric acid, and chlorate will become chloric acid, chlorite will become chlorous acid. So here we are reviewing about acid nomenclature once again from the chapter number 2. That will be very helpful if you review once again from the chapter 2. So acid from the binary compound ide ending, that is hydrogen chloride, drop the ide ending and the prefix, use hydro and suffix ix, the word acid. So hydro anion name ic acid, hydrochloric acid. So for this is for binary compound or binary acid which have ide ending, chloride. So chloride will become acid. When chloride anion will become acid, it will be HCl, and the name will be hydrochloric acid. So some of the nomenclature we have to remember here. and that will be asked in the questions. Acids from compound of the polyatomic anion ending 8, that is hydrogen phosphate. Drop the 8 ending, say the name of the polyatomic ion, add the suffix "x" and the word acid. So this will become phosphoric acid. Hydrogen phosphate will become hydrogen. So when it will become 8, we have to drop the 8 and add acid at the end. So phosphoric acid. Another example, acid from the compound with polyatomic anion ending in "ite", hydrogen phosphite. Drop the "ite" ending, say the name of the polyatomic anion, and the suffix "us" will be used as the word. So phosphorus acid will become hydrogen phosphite. Ite will change into "us", and 8 will change into "ic". So we'll see some example, then we can understand better. So this is a phosphate anion. Basically this is the formula of phosphoric acid, and its phosphate anion will be PO4 3-. So this is phosphate anion. Phosphate anion, when attached with the hydrogen, it forms phosphoric acid. When acetate ion, which is a CS3COO-, when have hydrogen, this form CS3COOH, acetic acid. This is acetic acid, nothing, just they summarizes. There are 2 carbon, 2 hydrogen, and 2 oxygen, and 4 hydrogen. Another example, sulfate. Sulfate is SO4 minus. When have 2 hydrogen, it becomes sulfuric acid. Bromide is minus, Br minus, will become bromic acid. Nitrite, NO2 is nitrite ion. Nitrite ion will become nitrous acid, will make nitrous acid. And then hypochlorite we have seen ClO minus is hypochlorite. When it has hydrogen, it called hypochlorous acid. So these are the nomenclature of the acid and their properties. Now next we will study about the base and their properties. Let's see what are the bases. So bases are the substances that react with or accept hydrogen ion. They increases the concentration of hydroxyl ion when dissolved in water. So base are just opposite of the acid. Acid increases the hydrogen ion, but base increases the concentration of hydroxyl ion, and base decreases the hydrogen ion concentration and the called proton acceptor. For an example, potassium hydroxide KOH. Another example, sodium hydroxide, ammonium hydroxide. These are the example of base. So substance that do not have contain hydroxyl ion to be a base. For an example, when water react with ammonia, it produces, or you can say when ammonia gas is dissolved in water, it produces hydroxyl ion and ammonium ion, and it is a weak base. That is why this sign shows that they exist in the equilibrium. And this is another example of base. So sodium ion and potassium ion, when dissolved in water, they are very strong base and they form potassium ion plus hydroxyl ion, and then sodium hydroxide when dissolved in water, it also produces sodium ion plus hydroxyl ion. So these are the ion base which increases the concentration of hydroxyl ion in the water. Another is the properties of bases. So base, proton acceptor, acids for proton donor, and base are proton acceptor. Base decreases the concentration of hydrogen ion and increases the concentration of hydroxyl ion. Base react with H plus proton ion to form water. Base are bitter in taste. Example you can is the soap. When soap goes in our mouth, it become taste as a bitter. So they are also corrosive as acid, and when they react with the organic dyes to yield a color change. So when base react with the red litmus paper, they turn it into blue. So this was about the base and their properties, and let's see the salt. What are the salt? So salt are the ionic compound that can be formed by replacing the one or more of hydrogen ion of an acid by the different positive ion metal ion. For an example, HNO3 is a strong acid. When you replace hydrogen ion with any metal ion, this will become salt. So another example is HCl. When I replace it with the sodium, so sodium chloride is a salt. This is the acid. So another example is S2SO4 is a sulfuric acid. When replace these hydrogen with the sodium, then this will become Na2SO4, sodium sulfate. So these are the salt example. And so salt have metal ion positively charged, and anion can be mono one element or polyatomic anion. So this was about the salt, base and salt and acids.